Alright, now we're getting ready to flip them over, but we got to deburr this. So I'm just taking a countersink, and this cast aluminum really does break an edge, just rolling a big countersink right in there. Now I want to knock this flashing off of here, so I'm using a 3M Scotch-Brite pad here. And then I'm just going to massage it off around the edge here, letting it roll over the edge that way. You could probably do it with a file too as well, but that's it, you know. That does it real nice for me. Alright, now we're ready to go ahead and put this in. It's in the other direction. Now we have to switch this parallel here just so that we got room there. There we go. Alright, now if we just came in here, this is at 0, so this should be just barely touching. Which it is, just barely touching, and you can see that we're hollow over there and we're hitting over here. Probably the way the wear originally was on it. So we're going to continue our depth from here, and we're going to go another 100 thousandths for our start. And then from there we're going to set a 0, and we're going to go ahead and skim across, and then we're going to take it out and we're going to measure it just to verify our last 25 thousandths that is projected to be at the end here. Alright, now here we go. Alright, we pop this out. Now our dimensions should be okay, 2 inches 125, 124. Alright, we're going to go ahead and we double check this side here. Same thing, 2 inches 125. Alright, we crank in the last 25. This will bring it down to the finished width here, or the thickness. got for the thickness here. Two 102, two 100. Alright, we'll finish this side up here and then we'll get on with the holes. Alright, we cleaned up our setup. We went ahead and put two parallels down here at the bottom, 1/2 inch in height, so that it'll give us a 1/2 inch underneath our part. And we go ahead and we clamp this down, give it a slight tap, and we go ahead and we slide the parallels out. And we're going to keep those up here on the vise. The two holes, we're going to do them in one setup. So we come over here, we're going to drill and ream that one. We're going to come over exactly the center distance and drill and ream that one there. Then we will take this part out and we'll come back and we'll do each one. We're going to do them as individual complete parts, so that that hole is in line and exactly the same distance from one to the other. Alright, we're going to set up our drill chuck here so we can locate this hole, and then we're going to go ahead and set up the drill and the reamer. Alright, I've worked out a combination here that's we're gonna go ahead and pull this out. We're gonna be running this 5/8 collet with a 5/8 rod. That'll locate that hole. Then we're gonna go ahead and put in a 1/2 inch collet. We're gonna go down, we're gonna drill that hole. Then we're gonna slip this into the 3/4 inch collet and we're gonna ream that hole. And then we're gonna come over here and catch this one here. The distance between center to center on these is 4 5/8, and that's what we're going to go ahead and use for center to center. We'll verify that with the readout, and these two are parallel with the back side, so all we're going to be doing is shifting side to side on this. Alright, let's go ahead and we're going to pull this piece out here, and a little light tap breaks that loose. And this is the 3/4 inch collet that will be going along with the reamer. And we're going to go ahead and lower our table down here because we're going to need to get our tools interchangeable here. Okay, we tighten it up. And of course, this doesn't have to be real tight. We just want to make sure it's not loose in there at all. And we come on over here. Now I like to go ahead and you can put your spindle in freewheel. Right here. And that way you can feel if it's actually binding with a round diameter here. and you can put it down in the hole and rotate it around. I'm going to call that 0. Alright, so we're not changing in and out at all. We're only going to be changing the side to side. And just a note, we are 0.989 for the in and out off of our 0 there. So we just kind of keep that in mind. So if that shifts, we've got that number. And we'll write that down, 0.89 or 0.989. And we'll just leave that up there in case we need it. Alright, so we got that set at 0. We go ahead and we break this loose after we put it in gear here. And we pull our straight shank and our collet out. Now we want a 1/2 inch collet and just making sure everything's clean. If there's any question, blow it out and clean it out. You don't want a chip getting caught in there. Okay, we need a little bit more height. Alright, we're going pretty slow there. That's 135 RPMs, next to the lowest. And we're just going to engage this hand feed so it doesn't suck on us if it tends to want to. We're just verifying the hole. It just looks, it sure looks like a lot, you know. And that's because we didn't open it up. We didn't open these up like we did the others with that O-ring groove. So I'm going all the way from the 5/8 out to the starting of the 55/64s to be just under for the reamer on the 7/8 reamer that we have. And that's, I was just looking at that and I go, man, that is a lot. So I'm stopping right here where I could easily change out right now, but we're fine. Back to where I was at, and we're going ahead and we're coming down. You know, I think just for general purpose, I'm just going to hang this parallel just under that edge there, just so if there's ever any downforce, I'm not going to accidentally move that. I keep an eye on that. It is semi-loose underneath there. Alright, stop it. We're going to engage the worm here, the feed. And we're going to go ahead, and it's feeding pretty good, so we're going to that's in 3. We'll see how that does. Instead of cranking it, I'd rather let the machine do it. Okay, we're at the zerk hole now. reminds me to go ahead and pull all the set screws out of here so we don't accidentally hit one. Okay, we're almost coming down through the bottom. Okay, we set 0 there for our future reference there. Okay, now we pop this out and we're going to pop in the reamer. We'll have to set that other, as long as we can get this in here now. I think this is as low as we need to go. Alright, and we're going to go ahead and lower this down to the lowest speed the Bridgeport goes, 80 RPMs. And here again, I'm just going to slip this underneath the edge there. And just like we did on the drill press there, I'm just taking it a little bit at a time here. So it doesn't get clogged. And there's our first hole. Alright. Nice. Alright, we're going to go ahead and move over, we said 4 5/8. And then we're going to check our fit here with the pin there. Okay, there's 4 5/8. And there's our 5/8 pin. Slight snug, just so it's not loose in there. And 4 5/8 is reading out too much. Okay, let me see if I can do this real quick, because I was getting in a pissing contest with myself, and all day long I measure four, which is say 4 inches. It's 420, but I put the math together. 4 inches here plus half one of the holes is 5/8. It's 4 5/8 all day long, and actually with the extra there, it was actually 4,650. Okay, so 4,650 center to center on every one of those. So I was wondering why I'm not getting that, and if I was to put in my 4,650 into the readout here, I would be way off the map. So this is what I did. I put, just to verify this, and I went ahead and I put my bushing on here, and I went back to the point here, and I could slide my sleeve down, and I could see that I'm actually 0 with that. I set 0 on my travel dial here, and then I hand crank this all the way over here until I came up with 4,650, and I'm exactly lined up with the hole. Okay, but I'm sitting here at 4 inches, 584 or 568. It's been in that realm there every time. Let me see here. Actually, right there, what was it? 568, exactly what I said. If I put it right on the money, where I was really nitpicking how close I was with the dial. So here is a case where something wrong with my glass slide or whatever on my digital readout, because here I'm not absolutely confident on my readout now because I'm finding an error in it. Alright, but at least I know that I can go ahead and set, and I can do this job with my dials. So I'm still going to plan on hitting this hole and then coming over and doing this hole here. And my math was right, and here the digital readout was failing. So somewhere I don't have time to do it now, but I'll have to pull that apart and then actually even shut it off and turn it back on. A couple other things, we'll just see if we can't reset it. Maybe it'll come back alive, or who knows. It's a 8-year-old system. You know, it's bound to have some flaw as age. You know, things burn out. I may have to get another set of slides for it. Okay, I just wanted to cover that real quick. I'm going to go back to my holes here now. Alright, here we go. This is the last one, and this is kind of how smooth the setup started running. Now we had a problem with the readout, and it actually is working now. And the first thing we do is we come back to 0. And what we also do is we make sure that we go past 0, and that we double check it with our dial. And we're going to be setting our dials quite a bit now because we don't trust the readout. This is like the problem I used to have when I first got the readout, is I didn't trust it. So I made the comment, it might be a female readout, but I was only saying because they're never wrong, and they have the right to change their mind when they want. Just it's a rumor I hear. Anyway, alright, so we set it apart here, and we eyeball that down here, and we go ahead and we tension that up, so we are holding at 0, and that's going to be creating the starting point. And we go ahead and we loosen this up, pull this out, and we put in the drill. Alright, and we're going to go ahead and change it up one speed here. Alright, we're ready to go. Bring it on down. And we let this feed in through there automatically. We move our parallels over just to keep one underneath the edge. We haven't had one of these parts slipped yet. But it's just a good habit to always have a downforce. When it gets down close to the bottom, it starts pushing the parallel out. And I knock the chips back in. Just went past the grease zerk fitting, the passage. Gave it a little interrupted cut there. Split out some of the chips there. Right there. Alright, we go ahead and we change out now from our drill to the reamer. Extend the reamer down just a little bit. Alright, and we'll slow this down one speed. All we're doing is clearing out those flutes to make sure they stay clean. No galling. And all the way through and back up. Alright, now we go ahead and we pull this one again. Any question, clear the chip. Don't stick it in there with a chip on it. Okay, finger tight. I use this for reference. Alright, now we go ahead and we come on over. And we go ahead and we hand crank this kind of over here. Now we know that 50s are marked right here. We're lined up there, and the readout now is reading 4650 or 449, 649, close enough within a thousandths. It, for some reason, it had a burp, and then it decided to work right. All right, we'll go ahead and we'll pull this out, put it in our drill. We want to speed it up one. Alright, and we engage it. Going through the grease cavity or the grease passage right now. We take a countersink, break that sharp edge, all four openings, I should say. Little. And there we go. Alright, now we're going to be doing a little dressing, pushing out our grease passages, making sure all that old grease and everything else is out of there, doing a good cleaning on them. And we got some prep work to do on the bushings here. Length issue, and we'll be taking care of that. And only because you can't order them exactly the length you want. And so we got them a little bit on the long side, but we're going to modify them and then we're going to press them all in, and then that will be complete, and we can start shipping these back to Brian, and he can start putting his mean machine together. Alright.